is ignore. I mean, why saying ignore is he was thinking that he was doing for a different batch. He spoke to Chetan was supposed to do the batch, and he was assuming that somewhere in between the courses there, so he started with task and function. I think that's what he was talking about in the session. So now I got the context. Are you all familiar with how to use GD? Has the session been done on how to use GD? So you're all clear with the shortcuts, and have you done any work where you have practiced some GD commands and other things? Okay, fine. Do you know what is indentation? Yeah, indentation is nothing but I'll show you an example. This could be an example of indentation where I have a function. I will not code everything like this. If I'm coding something inside a beginning, I will give a space. For example, here I'm giving a space, one tab space, so that the code looks easy to read. So there are some guidelines on how indentation should be done. And why I'm doing this revision is so that you have continuity with what I'm going to teach. Indentation is basically keeping a group of lines with a fixed tab space. How to identify a group? All the lines inside begin and end makes a group. So I have a piece of code which starts with begin and end. Here I have begin. Here I have end. Sorry. Anything below it should be spaced with one tab space. Here also let's say I have begin. So they should not be like this. You should keep like this. And again, here you should not have variable spaces like this. This is not user friendly. I mean, not easy to read. Okay. Rather, having everything with a uniform space is this is called as the tab space. I can even set the set tab stop equal to let's say 2. So each tab will only be 2 spaces. If I want to standard, we use is 4. You can even go with 8. Everything will be shifted by 8 spaces. So general standard would be to go with. Now, whole group can be shifted by one tab space by using virtual block concept in GD. You know, in GD there is a concept of visual blocks, not virtual, visual block. Using that, you can shift the entire block. And you can use set tab stop to set the number of spaces in tab. I think the rest of the things we can discuss as we go forward. I think the trainer has given you an overview of how model sim is used. Okay. First of all, do you all know what is model sim? Why we use model sim? Simulation. Okay. So what exactly is simulation? Let's try to understand. You see, for last 1 month, you have learned digital design. During that time, you have implemented some frequency dividers, frequency multipliers, some combinational logic, multiple things you have implemented. Let's say you have come up with some circuit. What is the guarantee that it works? It is correct circuit. I'll show you an example. This is an example of a 3-bit up counter. Assume this is an example of a 3-bit up counter. Okay, I will tell you that these 3 AND gates, these inverters, this OR gate, XOR gate, NOT gate, and 3 flip-flops put together makes a 3-bit up counter. How do I confirm that this actually behaves like a 3-bit up counter? That is where becomes the concept of a simulation. So what I do as part of the simulation is, I will take this circuit, I will develop a Verilog code using this behavior. Going forward, we will call that kind of model coding is called as structural model style. I'll explain you today what exactly is structural model. In structural model, we develop the code which is similar to this one. Then once you have developed the code, how do you prove that the code is actually working? We run the simulation. To run the simulation, we apply inputs. I will again give you an example to understand what is simulation. Let's say I have developed an AND gate. And some logic, right? So what exactly is the simulation is? This is my design. I'm trying to verify. We apply some inputs to it. We get the outputs. We check whether these outputs come in as per our expectation. So let's probably AND gate is not a good example. You take any design for that matter. I was showing you an example of up counter. This up counter, I will develop the Verilog code. And to that Verilog code, I will give clock and reset as inputs. I will check whether my count comes in this pattern of 0, 1, 2, 3, so on. Based on that, we confirm that this circuit is correct. If anytime I see that this behavior is not coming, then that means what? Somewhere things have gone wrong. Either you have used the wrong gate, either you have used some connection is missing. So to prove that whatever code you have developed or whatever circuit you have developed, we use the concept of simulation. Why simulation is important? Why do we need to do simulation? Because once you have developed this circuit, this will go into a chip. If this is not behaving properly, if it is not behaving like up counter, it is behaving in some other manner, then will my chip work fine? No. The same chip will go into my final product. Will it work properly? So simulation is a way of verifying the Verilog code you have developed. What do you do as part of simulation? Let's try to understand. What we do as part of simulation? We use a simulation tool which will generate the inputs as per your user requirement. And it applies those inputs are applied to the design. We apply inputs, what will come? Design will give the outputs. Based on that output, we check the outputs to confirm if design is working. There are various types of simulators. Model sim, Questa sim, VCS, NC sim. So the model sim, Questa sim, from Siemens. Earlier it used to be Mentor Graphics. VCS is from NC sim is from Athens. Then there is some Rivera, some tools are there. There is one more company. Okay, forgot the name of the company. But anyway, this is not very important for now. All these tools does the same thing. These are like, in a simple analogy, these are like all are bikes of different brands. One could be a TVS brand, one could be Bajaj brand, one could be Hero brand. It's like once you know how to ride a bike, other bike you can learn in a day. Same is the concept. So you should not be too much worried about which tool am I using. I mean, am I learning Model Sim, am I learning VCS? You don't need to worry because all the tools have a lot of things in common. What do we do typically as part of a simulation? Let's try to understand. When you run a simulation, what do we do? So what all steps are involved in simulation? I think other kind of might have given you an idea. What is that is done? First thing we do is create a library. That is Verilog. Then what do we do? Compile the files. It can be Verilog. Right now it's only Verilog. Let me not bring in system Verilog. Let's only talk about Verilog. Tell me, what does compilation do? It checks for errors. Okay. What else it does? It converts the Verilog code into object file in some design internal understandable form. See that? Sorry, tool understandable form. Now, what exactly is inside object you don't know. But object file is a tool specific format. So, which is the command used for this purpose? Verilog is the command we use for this purpose. Once you have done the compilation, what is the next thing you do? We do something called as elaboration. Let us understand what is meant by elaboration. I will give you a simple analogy. If I ask you to visualize the institute building, how will you visualize? The building has 4 floors. Each floor has this many rooms. This is the number of chairs in each room. So compilation means, what is compilation? The process you come to each floor and understand how many rooms are there, what are the facilities in each room. That is called as compilation. Kind of. What is elaboration? Is whatever you have understood about each room, you connect all the information. Then you have finally the building structure. So how does the overall building looks like? You have made up the complete idea. That process of tool connecting all the information is what we call as the elaboration. Yeah, you got the idea? It has compiled 5 modules. Let's say module 1, module 2, module 3, module 4, module 5. Finally, it has to come up with the structure. How the entire test bench looks like, entire design looks like. That process is called as elaboration. Elaboration, which is elaborating how the entire structure looks. So the tool coming up with the total environment structure. Again, elaboration is an internal process. How tool does elaboration is specific to the tool, we don't need to worry about. Once you have done elaboration, you can do the simulation. Elaboration is done using which command? VC command. Now you may say it should be simulation, right? But you take it as VC means elaboration. Then to run the simulation, you use run hyphenol. Now, is hyphenol compulsory? It's not compulsory. If you say 10 nanosecond means runs for 10 nanosecond duration. Run 100 ns means runs for 100 ns duration. Run all means runs till dollar finish is called. Now the question comes, what is dollar finish? What do you think finish should be? Finish the things, right? So whenever you develop a code, there is a concept in Verilog called as, you can call dollar finish. What dollar finish does is, wherever dollar finish happens, it exits the simulation. Simulation doesn't run further. So run all when you do, it will just wait for dollar finish to be called. It will not stop at 10 nanosecond. It will not stop at 100 nanosecond. It just continues to run. Till this point, are you clear? So let's revise again. So which is the tool we are going to use? Model Sim. When you run with Model Sim, how many steps do we do? 4 steps. What we do? What is the first one? Library. See, like about library, once you have created the library, you don't have to repeat it. It's like one-time work. Let's say you are doing compilation 10 times. Every time you don't need to create the library. But compilation has to be done whenever things are changed. Let's say this room structure is changed. So you, without knowing this, can you give the complete information? No, right? When this room is changed, what should you do? You should come to this room. You should see what are the changes. Then that will become input to the elaboration, right? But library won't change. Library name will be same. Now the question is again, what exactly is library? Why do we need library? Library is required because you have got various object files. When you are compiling, what is the output of a compilation? Object file. When you compile some Verilog code, the output that comes out of Verilog code is the Verilog compilation is the object file. Those object files needs to be stored somewhere. The place we store the object files is called as library. The place where we store the object files is called as library. Is that clear to you? Okay, next. What is elaboration? We have understood. Which command is used for that? VCC. Then we have understood simulation. For now, this much is required. This much is sufficient. As we go forward, how much we need to know more about tool, we'll discuss. We will divide the next few lectures into 2 parts. I will give a half an hour overview of how the Verilog language has evolved, because before we start doing anything in Verilog, we need to know why there is a need for Verilog language, right? Other than Verilog, there are so many other languages out there. Which are other languages, you know? C language is there, C++ is there, Python is there, Java is there, .NET is there. With so many languages available, what was the need for a new language called as Verilog? First, we need to understand that. Let's spend some time to understand. So before we go into the presentation, I'll give you a background why the Verilog has evolved. You see, Verilog is a hardware description language. Here stands for what? Hardware description language. What does this statement mean? Let's understand it as a plain English. This is the language used for describing the hardware behavior. So Verilog is the language used for describing the hardware behavior. Same thing, I have rephrased it in a different way. Okay. Now the question comes, why can't we use C or C++ for this purpose? What is the specific need for a Verilog when we have other languages like C or C++? So let us try to understand. Okay. So to understand that, we need to know how hardware differs from you know that which language can we use C language to develop the software? Yes, right. Anything in the world can be, any software in the world can be implemented in C language. It is the most basic programming language. If that is the case, why can't we use Verilog for defining the hardware? That is where we need to understand how hardware differs from a software. So the first difference is hardware has a structure. Software doesn't have any structure. It is just an executable code. It is just an executable code. Simple example I'll ask. You go to a restaurant. Okay. In the restaurant, at the billing counter, what do you see? One machine which he uses for generating the bills, right? If you ask, how does the software look like? Tell me the structure of it. Tell me the structure of the billing software that is there. Will you be able to tell that? No, right? Why you can't tell that? Because it is just an executable code. When he runs, it's a piece of code that gets executed. So that software doesn't have any structure. Now, what exactly do I mean by structure? My laptop has a structure. My laptop has a structure. You can define laptop how it looks like. It has got one USB port. You can tell it has got one SD card port. You can tell it has got a keyboard port. It has got one VGA HDMI port. This concept is what I call as a structure. A software doesn't have anything like a structure. That's the first difference. Second thing is software executes in 0 time. Software doesn't need any time because even when you are developing any C program, you don't give any delays. It all gets over in 0 time. Hardware has a concept of time. Software doesn't have any concept of time. Let's understand line number 2. Hardware has a concept of time means you take a simple example of a traffic light. You see the traffic light for first 50 seconds it will be in red. Next 30 seconds it will be in yellow. Next 20 seconds it will be in green. So if the hardware is in a state where initially it was in red, then it moved to yellow, then it moved to green. So hardware has a concept of time, concept of state and time. Where with state changing with respect to time. State changing with respect to the state changes with respect to the time. Whereas software doesn't have any concept of time. The third major difference is hardware has concurrent executing process. Software executes in sequential manner. Let's understand the line number 37. What is line number 37? Hardware has concurrent executing process, whereas software executes in sequential manner. Let's understand the meaning of it. You take a simple example of my laptop. Right? In my laptop, there is a presentation is being running. And my hardware is running the presentation. Right? When I go here, when I change it, the presentation changes. This is happening first thing. Second thing, what is happening? Whatever my laptop image is there, it's coming to display projector. So the second process is what? Data going from my laptop to the projector. Third, what is happening? People who are sitting somewhere else, due to this online meeting, they are able to listen to my voice. They are able to listen to the audio, video, everything, right? They are able to see that. So, do they run? Are they happening parallelly? Or are they running one after another? Parallel, right? So what is running parallelly? While I am talking, they are listening. The same data is getting displayed to the projector. Okay. And at the same time, my this thing also is changing. Whatever you see here, it is all changing. All of this happening concurrent. Do I have 3 different laptops for that? Or do I have 3 different hardwares for that? All of them are happening where? One single hardware. Okay. I have listed only 3, but there are a lot more things that are happening in hardware which we don't know, right? Okay. Which we are ignoring as well. So in summary, hardware requires a special behavior where it needs to execute multiple concurrent processes. Whereas in software it doesn't work like that. In software everything executes in one sequential manner, one line after one. It executes in a first line, second line, third line. It never executes in parallel. So this is the 3 differences. This is where the C language is not suitable for hardware purposes. What is meant by that? C language cannot be used to implement this structure. C language doesn't have a concept of state and time. C language doesn't support concurrent executing processes. Let us repeat again. So we are now trying to understand why C language cannot be used to implement a hardware. To understand that, we are understanding what are the differences between a hardware and a software. What is the first difference in the hardware? Hardware has a concept of structure. You can see this mobile phone has a structure. What do you mean by mobile phone has a structure? Mobile phone has a ports, USB port, SD card port, different ports, which a software doesn't have. Okay. How do we get the concept of structure in Verilog? You can tell clock is the port, reset is the port, count is the port. On top of that, you can even tell that it has got an input, it has got an output, everything. Second. What is the second difference? Hardware has a concept of state. Again, I told you example of state, right? Traffic light controller. Right now, currently green. For next, it changes to yellow. And there for 20 seconds. I'm just giving an example. This is a particular requirement of hardware which software doesn't have. Next, hardware has a concept of concurrent executing process which software doesn't need. Because of these 3 reasons, actually. Because of these 3 reasons, we need a new language. That is where Verilog is implemented. So what exactly is Verilog? Verilog is C language plus new constructs added to support above 3 concepts. I mean, not everything in C, part of C language. For example, C language has something called as binary tree. It has got linked list, which a hardware doesn't require. A hardware doesn't require the linked list, binary tree, union, enum, structure. It doesn't require all of them. So then you may say, why are you writing? I'm trying to make you feel comfortable with Verilog. Verilog language is similar to C language in many respects, plus new constructs. New constructs added to support above 3 concepts. Which are the 3 concepts I'm talking about? Concept of structure, concept of of state and time, concept of concrete execution. So there are new things that are added. If I have to tell you one thing, Verilog is among the simplest programming languages in the world. Verilog is among the simplest languages to learn. I'll tell you the reason also. Okay. If you take C language, how many things you come across in C? So many things. Operators, data types. Even in data types, what are the things you come across? In shorting, login, char, struct, union. So many things, right? Verilog, in comparison, has only 4 data types. Integer, real, prime, that's it. Now, whatever operators that are there in C language, what are operators you might be aware? Arithmetic operators, equality operators, logical operators. They're exactly same in C language, Verilog. Whatever operators, if you know. Now you may say, I never studied C language. So you don't need to come prepared with them. We will teach everything. Now, then why am I comparing this? Is to tell you that it is simplest language to learn. You don't really have to worry much about Verilog language. As a language, it's very simple. What is difficult part of our whole course in Verilog is we are going to take some designs like FIFO, interrupt controller, SPI controller, few designs we are going to take. So understanding those designs, implementing those designs using Verilog will be the difficult part. Learning Verilog is very easy. How much easy it is? If you take one language, let's say Telugu, Kannada, any language you take, it may have thousands of words. Language you take, any language you take, it has what? Thousands of words, right? You take a dictionary, it will have thousands of words for any language. You know Verilog has how many words? 40 words maximum. 40 to 50 words. Compare it with any other language. Take any other language. Compare to that, Verilog only has 40 to 50 words. What are those words we are talking about? Module, module, begin, task, function, integer, real, time. Like that you list down, it will come to around 40 to 50 words. These words are what I am calling as constructs. These words is what I am calling as what? Constructs. Verilog language constructs. So the task is a Verilog language construct. Function is a Verilog language construct. Integer is a Verilog language construct. So all you have to do is what? You need to understand what are these 50 words, what is the meaning and how to use these words. Simple, right? It's simple compared to some other language, it's very simple. I think we deviated a little bit. Let's come back to the original topic. So where are we? We are trying to understand how the Verilog language has evolved. So let's go through the presentation. Now that I have given you the background, you will be able to understand this easily. You see, electronics has evolved around 1960s. Design consisted of fewer transistors. If you have between 10 to 100 transistors, it's called as what? SSI. What is that? Small scale integration. If it is 100 to 500, it's called as medium scale. 500 to 20,000, large scale. Anything more than 20,000, very large scale. What exactly are these numbers? What are these? Number of transistors. That means a design which is based on medium scale integration will have anywhere between 100 to 500 transistors. Design with fewer transistors can be manually modeled. Let's say I have only designed with 5 transistors. I can manually tell this is the AND gate, this is the drain. Connect this drain to one more transistor gate. Source of this connect to one more transistor. I can manually model this. I can come up with this circuit manually. But as we increase, right now how many transistors did I use in this? 3. When it goes to 20,000 or more, a big number, you cannot manually do this. Is it possible to do this manually? Not possible, right? That is where, however, as the transistor count increases, it becomes difficult to model the design manually. So the current complex designs like mobile phone SoC, the server SoCs, requires billions of transistors, which can't be modeled manually. You cannot model them manually. So that is where comes the requirement for automation. You need to automate it. So that is where we come for the solution. So how to automate it? So the solution is what? Implement the design behavior using higher level description language and convert this description to data. Understand the design. Implement that using a higher level description. Now the question comes, what is this higher level description? Let's understand what is meant by higher level description. This is the up counter behavioral code, which is also called as higher level description. The same up counter. This is how the code looks when I do it using gates, AND gate, OR gate, XOR gate, 3D flip flop. You remember the up counter circuit diagram I've shown? This is the low level description. Why it's low level? You're explaining at AND gate, OR gate, XOR gate, D flip flop. That is why it's called as what? Low level description. At very low level you're telling this AND gate is there. What is description means? If I have to tell you about this building, this is where brick is there. Above this brick, one more brick is there. That would be called as what? Low level description. What will be higher level description? There is a 4 floors. In 4 floors, these many rooms are there. That's all. These rooms are made up of bricks. Now, which brick did you use? What is size of brick? Which we don't worry. What is low level description means? You start from the explaining at brick level. These many bricks are there. These bricks are arranged in this manner. So, which is easy to me? Explaining at the brick level or floors level? So that is what is Verilog does for us. Verilog lets me define everything at a top level. Rest of the things, there is a process which will automatically. So, you see both the codes. You see how many files are opened here? 2 files. One is get level. One is up counter. Do you see how many files do you see? 2 files you see. I will open both the codes parallelly. Tell me, among the left and right side ones, which is easy to understand? Left one, why it's easy? It's more like English. Always at the positive edge of the clock, at every positive edge of the clock, if reset is applied, make count equal to 0. Else increment count by count. This would be even easier. Very simple. If reset is applied, count equal to 0. Simple example, you go to traffic light, you apply the reset, what will happen to the count? It will become 0, right? When you reset, it will become 0. When you don't do anything, what will happen? The count keeps increasing. This is called as high level description. At high level, you're telling. This is called as low level description, where you are explaining at the gate level. Tell me which one is important. Which one is important? Both are important. Both are important. Then, what is the which one are we going to use for developing purpose? We are going to use it. Then why is it important? It is important because this is what actually gets manufactured. Your phone doesn't have always code. Your phone doesn't have if-else code. During the whole development process, what they do is, if I'm a Verilog designer, a person who is developing the code, I develop my code in this manner. Then I have got a tool called as synthesis tool. What is the name of what is the tool? The synthesis. To that synthesis tool, you give this as an input. This file actually. What is the output? This code automatically. Let me explain again. High level description is like very much like English. Can you see it's like English? Always at positive edge of clock. If reset applied. Now then you may say, why don't we use English at all? English itself, right? We can write English itself, right? Thing is, my model sim doesn't understand English. My model sim doesn't understand English. It only understands what? Verilog language. Okay. Because the model sim tool is developed to only understand Verilog language or VHDL language. You may say, I will come and go, I will go out and come. My model sim doesn't understand this because it don't know the meaning of what is will means, go means, out means. It doesn't understand. It has got its own limited set of words. What are those words? Always, passage, begin, if, else, end module. It has got some list of around 200 words. What we call as Verilog language constructs. These 200 words are called as what? Verilog language constructs. Only that only it will understand. Rest of things it doesn't understand. Then you may say, sometime back you said 50, now you are telling 200. So 50 is what we use day to day. Even in language, Telugu language, there are thousands of words which I don't know. Right? I know only 20% of words in my language. Everyone. Right? Your native language only, there will be 80% of words which you probably won't even understand. Same is the case in Verilog also. Out of the whole language, you frequently use only 30%, 30 to 40%. Remaining 50-60% you never use. You don't find any use. That 30-40% happens to be the 50 words. What you see here? Module is one word you use frequently. Input, output, reg, always, passage, if, end module. Okay. Biggest code you take, a code which will be 1,000 lines also, they will consist of these words. I mean, they will only consist of 50 words frequently used. So that level of description is called as behavioral style, or also called as higher level description. Now do you understand what is higher level? At higher level you tell, if reset is applied, make count equal to 2. Else, count equal to 1 plus. Low level means you tell this AND gate will be there, this is how AND gates are connected, this is flip-flop gets this input. Okay. Luckily, you don't have to do this. You develop this code, you have a synthesis tool, you give this as input, it automatically gives us as a. That is what is. Implement the design behavior using a higher level description language. Convert this description to a level. What is that concept is called as? Convert is, it is called as synthesis. Do not implement design directly using transistors. Do not start with gates and transistors. Start with what? Higher level. Rather implement using higher level description. Use EDA tool, synthesis tool, to convert this description to gate level and further to transistor. EDA tools, EDA stands for what? Electronic Design Automation, plays a major role in this process. Okay. If EDA tools were not there, let's say synthesis tool was not there, assume that in this world there was no synthesis tool. Then all these mobile phone laptops would not be possible. They were impossible. Without a synthesis tool, we wouldn't have laptop, we wouldn't have mobile phone connections. Because synthesis tool is the one which made it possible to convert the Verilog code into gate format, gate level format. What is meant by higher level description? Do you understand? I have already explained what is meant by higher level description. You write more like English, I just told you. Above code is given as input to synthesis tool, which converts the which will convert it to give equivalent gate level description of the code. Gates can be converted to transistors. That process is called as what? Layout. The person who converts the gate level gates into transistors is the layout. Okay, I was telling you about what is the language is going. I told you that you need a language which will do the high level description. That is where I asked, let's say we asked ourselves a question, can we use C language? Answer is what? No, we cannot use. Why we can't use? Because there are three requirements in a hardware, three special requirements in a hardware, which C language cannot fulfill. Structure, state and time, and the concept of concurrent process. These three, C language cannot fulfill. See, C and C++ are used for implementing software behavior. We can't use them for describing hardware behavior. I have already explained how hardware differs from software. Concept of structure, concept of state and time, concept of concurrent execution process, concept of concurrent running process. Now, then what is Verilog, what is VHDL? It's like two languages which solves the same purpose. Even VHDL can be used for hardware description purpose. Even VHDL is also called as hardware description language. Hence, there is a need for new language with additional features to describe the hardware specific requirements, which C and C++ don't have. Verilog and VHDL are developed for this purpose. Simple difference is Verilog is used in US-based companies, VHDL is used in European-based. That's the difference. Now everyone is moving to Verilog. Even European-based companies are moving to Verilog. I think it's all summary what we have discussed. Now, I was telling you that Verilog language supports all these three concepts. What are those? Concept of structure, time, and the concurrent process. This is how we can define a structure in Verilog. Please read this once. You can define, this is the design name, these are the ports, these are the directions. I can tell clock is the input port, address is the input, read data is an output port, selection is the input. I can give this kind of directions in Verilog, which is not possible in C language. In C language, everything is a function. Everything you develop in C language is what? Function. You know functions in C, basic idea you have. You write main function, you can write any function. There is no concept like module and declaring the ports in C language. Did everyone understood this concept? Next. Concept of time and state. I'll explain you to a simple example. Do you know the relationship between frequency and time period? What is time period equal to what? 1 divided by frequency. Are you all clear with this? If one clock is running at a clock, running at one hertz frequency. What is the time period? What is the time period of this clock? 1 second is the time period of a clock which is running at 1 hertz. Here, if using this clock, using this one hertz clock, I want to implement traffic light control. What is my requirement? Using this 1 hertz clock, I want to implement traffic light control. 1 hertz translates to how much time period? 1 second. So if I have red light which runs for 50 seconds, how does the clock look? You know, right? What is time period means? If it is 1 second, tell me what is this distance? It is half second. What will this be? So 1, 2, 3, 4. So what is this distance then? Time. 3. 1, 2, 3. So in summary, if I have to get 50 seconds time, how many edges I have to count? How many positive edges I have to count? 50 positive edges I have to count. So if I develop a circuit, if we develop a circuit which counts 50 positive edges, then it will mean 50 seconds of delay. Tell me what is the circuit is called as? What is the circuit is called as? This is called as counter, no positive counter, counter. This is the same thing that you learned in digital design. Digital design trainer has taught you some counter, right? These are the counters only that you have discussed. Okay. So what does the counter will do? It counts the positive edges of clock. So in this case, why we are counting only 50? Why we are counting only 50 edges of clock? Because we are using a 1 hertz frequency, which means 1 second time period. To get 50 seconds, you have to count how many edges? 50 edges. This is how traffic light controller works actually. This is how the traffic light controller actually works also. Where it has got a clock. But only thing is, it won't be 1 hertz. It will be bigger frequency. As the frequency goes up, what happens to the time period? It will come down. It will be down, right? Because of inverse relation. As the frequency goes up, time period will be less. As the time period less, you have to count more edges. But you got the basic idea how the concept of time works. This is how the concept of time works in every hardware. It can be a simple thing like traffic light controller. Even it could be a complex things like my mobile phone. Let's say right now, my phone is off. I keep it stopper. It counts. Let's say 1, 2, 3. Even in that, count is equal. Now, can you please read it? Read both of them. It can check for positive edges. And through that we can count the number of edges. Once you count the edges, you know the time. So you know that when you count 10 edges, it means this much time. That's how you can get the concept of time. Coming to concurrent running process, Verilog has a concept of always blocks. If you want 3 processes, you have to use 3 always blocks. Then you get 3 concurrent processes. What is always block and how does it translate to a process? We'll discuss right now. Let's not go deep into it. I'm just trying to help you understand why do we need a new language called as Verilog. So Verilog is used for implementing hardware behavior. Because of that, it's called as hardware description language. It is not called as a programming language. So Verilog is not a programming language. Whereas C and C++ are what? Programming languages because they are used to develop the software. You understand why we call Verilog as hardware description language? It describes the hardware behavior. Using that language, you tell how mobile phone hardware will behave. That behavior finally converted into mobile phone hardware itself. Any questions so far? Clear, right? So this should have given you a basic background of what is Verilog language and how Verilog language has evolved. So throughout this next 1 month, you have to remember that Verilog is a simple language actually. If you start with the assumption that it's a very complex thing, it will be complex. But I've given you the logic why it's simple also. There are only very few things you have to learn in Verilog. We will start with simple concepts like implementing of combinational logic using Verilog. Once we are done with this, we'll go to sequential logic. Then we'll go to designs which involve both combinational logic and sequential logic. So we are going to learn the whole Verilog in 3 steps. Learning how to implement combinational logic. Second, sequential logic. Third, involving all both of them. So as part of this combinational logic implementation, we will implement every combinational logic circuit we studied. Everything. You ask me, will you implement comparator? Yes. Will you implement multiplexer? Yes. Will you implement encoder? Yes. Okay, let's say we do 80%, you should do remaining 20%. You should not have any doubt if someone asks you to implement decoder. You should know decoder, this is how it functions. Then you should know this is how Verilog code will look like. Okay? So that is what we are going to do. So this may go for 1 week to 10 days time, but we will complete all these things. So let us start with the implementation of the combinational logic. Before we go to that, let's try to understand the difference between combinational logic and sequential logic. Combinational logic output depends only on current inputs. Sequential logic output depends on current inputs and current state. One of the primary difference you will see in sequential logic is clock will be there, here clock won't be there. A combinational logic, so and do you generally give clock as an input? No, right? Whereas if you take any sequential logic, clock is compulsory. To implement a combinational logic, you can even use C language. Up to combinational you can use because a combinational logic don't have a concept of time, hence C language is also sufficient. Anyway, not to confuse you much, we'll start from the very basics. Okay. We are going to implement all of these things. If you feel that something is missing, please let me know. What do you mean by missing? During digital, our trainer has taught me this circuit, but it's not there in the list. You can tell me, we will do that also. So first let's start with a very simple thing, that is half adder. all above circuits, we will implement three modeling steps. One is behavioral, one is data flow, one is structural. So what exactly are these three? I'll explain. See, behavioral means high level, structural means low level, data flow means mid level. For now, understand in that manner. Maybe 1 or 2 sessions later, you'll understand what exactly is what. So first, let's start with hop adder. Let's start with hop adder. Can you draw the simple diagram for a hop adder? If I tell you this is hop adder, how many inputs will be there for a hop adder? What are those inputs? A, comma, B. What are the outputs? Some comma, K. So when it comes to Verilog implementation, you just have to remember how many ports are there, what are their directions. So that will translate into the structure. Hop adder dot B. What is the name of the file? Hop adder. B means what? Verilog. Like C program you end with dot C, C++ with dot CPP, same is. Now first thing what I have to do? Module. Everything Verilog is a module. Every block is a module. If I have to tell laptop as a Verilog code, module laptop. Like everything in Verilog is a module. What is the name of the block here? Please remember this. I will ask you to do full letter. Now after this. Whenever you write module, you write opening brackets and just say end module. Here. Then here you have to write the list of ports. What are ports you see in the diagram? A, comma, B, comma, some, comma, carry. Now comes the simple thing. What is the direction of A? Input. Output. Some, comma. Till this point, is it clear? Nothing complex, right? You just have a design where you know the directions. Without knowing these things, will you be able to do this? Right. So that is where your understanding has to start from here. First, you should be able to visualize a half adder will have 2 inputs, 2 outputs. That you have to write. Next. What is the Boolean expression for half adder sum? A, XOR, B. Carry? This one. We can simply do it in this manner. Assign. Assign. XOR has a symbol. What is the symbol of XOR? Yeah. And what is the symbol? So this completes the half adder Verilog. Nothing very complex. Whatever you learned in digital, you just have to put it. What did I do? I wrote the same expressions. We have to use a simple concept called as assign. Assign means, what do you mean by assign is? Anytime, assign means, anytime A or B changes, S and C gets updated automatically. You understand what does assign will do? Anytime A or B changes, S and C gets updated automatically, immediately, and immediately. At the same time, it gets updated. That is how half adder works, right? Anytime you change the output, output also gets changed immediately. This style of modeling is called as data flow. What do you mean by data flow? A and you're XORing A, B, that is going to S. You're ANDing A, B, it's going to C. It's like a flow of data. Can you see data is flowing from one point to other point? That's why it's called as data flow modeling. The data is going from one point to other point. This type of modeling is called as data flow. I will do one thing. Is it correct? It is wrong. How do I prove that it is wrong? How do I prove that it is correct, or how do I prove that it is wrong? That is where we need a concept of simulation. We need a concept of simulation for the purpose. What does simulation will do? As part of simulation, I have told you two things. We apply inputs, we get the outputs and check the outputs. We will apply different values of A and B. We will apply different inputs A and B and check whether sum and carry comes properly out. Based on that, we can confirm that either this is correct or this is wrong. So the process of applying inputs, collecting outputs and checking the output, the whole process is called a simulation. Someone who does that is called a simulation process. So let us do that. To do a simulation, what is the primary requirement? I need to apply the inputs. The component which generates the inputs is called as test bench. So I am now going to develop a test bench. So let me first show you how does the test bench looks like. So what are the two things a test bench does? Generate and apply inputs to the design, collect the design outputs, check those against the expected values. Please read it again. How many things test bench does? Two things. What is the first thing? Generate and apply inputs to the design. Second thing, collect the design outputs, check those against the expected values. Okay. I'll be asking the same thing after 3 months. I want you to tell the same answer. Means throughout as a verification unit, these are the only two things you do. Whenever someone says they're developing a test bench for a big design also, they're still doing the same work. What are the two things they're doing? They're generating and applying inputs to the design. When you apply input, what will happen? Output will come, right? That output you check whether it is coming as per your expectation. Okay. Let's say someone with 15 years experience in Qualcomm or Intel, who is developing a test bench. He's also doing the same work. What is the work he's doing? He is going to generate and apply inputs and he's going to check the outputs. Just that type of inputs you apply will differ, right? My laptop will require a different type of inputs. Mobile phone will have a different set of inputs. Half adder will have a different inputs. Because of that, the pattern of inputs you apply will differ. But the fundamental concept remains same. What is the fundamental concept? Generating and applying inputs is one concept. Second thing is what? Collect the design outputs and check those against expected values. This is the fundamental concept. Every test bench does. The most complex test bench or the simple test bench we are going to develop now, both does the same work. Even when we learn system Verilog, even when we learn UVM, the concept of test bench doesn't change. Then what is changes is the way you generate and apply inputs will become simpler. The way you collect outputs and the way you check them will become simpler. So as you go from Verilog to system Verilog, generating inputs will become easy. The way you do it. Collecting outputs will become easy. Checking will become easier. Again, when you go to UVM, it becomes even more easy. But the fundamental concept of a test bench remains the same. So now let us start with developing a very simple test bench. Test bench of header. It includes half header module PD. Let me explain what exactly it is. We are including half header. Why we are including? Because I will need the definition of half header in the test bench. This is how a test bench you can visualize in a real life. Okay, this is just for visualization purpose. Okay, let's say you are verifying a multiplexer. What it will involve is you have a test bench. The table is like a test bench on which you are placing your design. You are connecting the ports, and from here you apply the inputs. Apply various inputs. You get the output. Then you check whether that is good or that is bad. You check whether that is good or is that bad. Any questions so far? So with this understanding, first thing we do is what is the first thing we did if I wanted to verify a design? I place the design on the test bench. This table is like my test bench. So this table is my test bench. What am I doing? I am placing this design on the test bench. That in Verilog terminology is called as instantiation. That word is called as what? Like placing my design onto the table is called as instantiation. So let us understand what is meant by instantiation. This is called as instantiation. You write the module name, you write the DUV. This is called as instantiation. Is placing the laptop is sufficient, only sufficient. What else you have to do? You have to connect them. So you have to connect the ports. You have to tie my laptop has some ports. My table has some ports. I need to tie both of them. Understand? See these red lines you see, red dots you see? These things you see? I need to connect them. Only then I can give the inputs, right? Without connecting, how can I give inputs to my design? So for that purpose, what we do is, what are inputs I have to apply? A, B. I declare them as reg. Right now, just understand that we have to declare it as reg. Outputs I have to collect, which I call as sum, character. I just connect the same things. A, B, sum, character. These things are the ports present in the test bench. Things that are declared in the test bench. That I am connecting to my design. Once you have done the connection, will it verify automatically? Let's say this is my table and I place it on that. Will this design get verified automatically? No, right? It will not get verified automatically. What do I have to do? I have to apply the inputs. I have to apply the inputs. So let's now understand how we are going to apply the inputs. For that, Verilog has a construct called as initial. You remember there are 50 constructs. One of them was construct is initial. I told you right, Verilog language has 50 words you have to learn. Let's not use the term construct words so that it will be easy for us to understand. Okay. Like in English, going is a word, coming is a word. In Verilog, there are 50 words which we are going to use. That's all. After 50, you won't use anything more. So one of the words we are going to use is initial. Initial is like, as the name suggests, what you want to start initial. What is that you want to run initial? Is this. So here, I want to make A equal to 1. I want to make B equal to 1. After some time, I want to check what is the output. For checking purpose, I'll do one thing. Now again, display is one more word, which is similar to printf in C language. In C language, are you familiar with printf? Display is very similar to that. It displays the value things. A equal to percentage %B, E equal to percentage %B, A comma B. A comma B. Similar to this, apply more inputs. How can I do? I copy line number 10 to 14. How many lines is it? 5 lines, right? What is the given shortcut to copy those 5 lines? 5 by 1. 5 by 1. We copy. I came here, I paste. Now what I will do is, I change it to zeros. Like this. 1 0. Something like that I did. Our only thing is display instructions. So how this code works is, as soon as see, when you made A equal to 1, B equal to 1, where does this input go to? This will become 1. This will become what? 1. Do you agree? It's like I have connected wires. Connected wires here. I made this equal to 1, this equal to 1. What will happen to these points? They will also become 1, right? But because they are connected to the wire, they will become 1. When you make it 1, 1, what will happen? Some output will come. Where does that output come in my case? Essence. I'm just displaying essence. You understood? I have applied A comma B. Now I will check whether SMC is coming properly or not. To run this, I'll open question sim or model sim. Both of them are same. For a Verilog language perspective, both question sim and model sim are same. Whichever directly I am developing the code, I'll go to that folder. Copy address. When I go there, what will I do? CD brackets, flower brackets inside that. CD flower bracket inside that, just paste it. Control V. Enter. If you do PWD, where are you right now? In that folder where I am developing my files. Now, what is the first thing we have to do? VLib work. Actually speaking, question sim I don't need to do. In model sim, you have to do this. Then VLib work. Now, when I did VLib work, what happened? Work library got created. Do you see the directory got created? Earlier, was it there? The work library, was it there when I started the project? Why are we doing this work library? I'll show you. Now, when I do vlog, PB format, it got compiled. Few things got created actually. See, these are in its internal format which you don't understand. This, what is the format of this files? We don't understand. But what it has got actually is the definition of half adder, definition of the test bench, everything is present in this files in its own format. So, what have we done with it right now? What is the stage called as? Is it compilation, simulation, or what is it? Vlog is what? Compilation. What is the next stage after compilation? Elaboration. Vsim. Okay. In my tool, the one which I use, I have to use some separate commands. You don't need to do, but I have to. These things these two words I'm using, right? You probably don't need to do in your models, but in model, first as in the one I'm using, I have to pass those options. For now, you can ignore them. Okay, for you, the command will only be space t. That's all. When I run it. Now, what is happening? Elaboration is happening. What is meant by elaboration? Tool is trying to understand the structure. It has come up with this structure. This is what tool has understood. Please go through that. What is the structure tool has understood? Tool has understood that at very top level, what is there? TB is there. Below TB, what is there? DUT. What is DUT actually? Design and test. What exactly is design and test? Software. Name of the software is DUT. And below DUT, what is there? Two assign statements are there. You remember the Verilog code I developed using assign statement, the data flow modeling I said? This process where tool came up with the structure is called as elaboration. Simple elaboration, it didn't know that this was a structure. It only know that there is a TB, there is a DUT. When we did elaboration, it has done this connection. Once it knows the structure, now I can run the simulation. Run. Is it behaving correctly? I will copy. Is it correct? Which line number is correct or which line number is wrong? First one is correct. Yes. Second one? Wrong. Third one is also wrong. Right? So where do you think is the mistake? Is the mistake with sum or is the mistake with carry? Right? So this process is called as debugging. What we are now doing is called as debugging. We are checking the outputs, whether outputs are coming as per my expectation or not. Is it coming as per your expectation? No. So now we are doing debugging. Okay. This is called as finding the issue. We have found the issue. Okay. Then let's analyze the issue. Where is the mistake is coming? Now if I go to the code, do you know where is the issue? Okay. Now tell me, will you debug sum or will you debug carry? So that is what is important. You should not debug a place where there is no issue. You should debug only the place where the issue is present. So you should debug line number 8, not the line number 7. That is important because if you start debugging everything, there will be thousands of lines. You don't know. You can't check everything. So you can clearly see that there is an issue. What is the mistake? This is called as fix. What we did now is called as a fix. Issue happened because there is some mistake in the code. So debugging is a process of identifying what is causing the mistake. What is debugging? The process of identifying what is causing the mistake, things to go wrong. Then what we did now is called as a fix. You are fixing. Then once you fix it, then you again run this process. See, we have to run these steps again, right? Do I have to run line number 3 again? Not required. So only these steps I have to run again. So what I'm going to do is, I'm going to copy them. I create one file called as run.do. Then I can run this. So to run this, do run.do. So what is the advantage of benefit of doing this is I don't have to run each step. I can put together multiple steps and do this. Now is it behaving correctly? You can see carry is coming 0. Last it is coming proper. Okay. This is like this process. What now I did is called verifying the fix. You found the issue. You did the update to fix the code. Now you are verifying whether the fix is working fine. Any questions so far? Half adder can be developed in 3 styles. One is data flow, one is behavioral, one is structural. We have done data flow. Let us now do structure. How does structural look like? Structural means in terms of gates, how does it look like? One XOR gate, one AND gate. Very simple. Either use gate or structure. I'll do for 15 minutes and we'll end the session. Is that fine with everyone? When I don't instead of going for a break, we'll end the session after 15 minutes. Is that fine with everyone? Okay. So the difference in gate level is very simple. XOR. Instead of writing assign statement, you use the gates directly. XOR gate and AND gate. The standard convention is, the rule is that output first, input stage. That's the rule. You cannot write like this. You ask, can I write like this? Wrong. Because rule always assumes that first one is the outputs, remaining things are the inputs. Any questions so far? Clear, right? Now, when I have to run this in my test page, do I need to change these things? Nothing will change. Only thing I have to change is only the file name I need to change. Because when I change this file name, what is happening is when I'm saying include half-adder.gate, I'm asking to my tool, I'm telling to my models in tool that use this definition. Don't use the other definition. I'm telling that since you are verifying a half-adder gate level code, use this definition. That's what I can now run it. Is it coming fine? Okay. It's coming fine if you can notice. Anyone has questions till this point? Okay. How do I confirm that it's actually running gate level? What is there below the DUT now? XOR and earlier what was there? Assign. So it has now picked which definition? Gate level definition has picked. Clear? Now what is the third step that is pending? Behavioral. Behavioral means using always means. Remember, data flow means assign. Behavioral means always. Structural means using gates. Gates are some other existing structures. Let's write down what is what. Behavioral means what? Use always. Data flow means assign. Structural means gates are existing modules. Already whatever modules you develop, you have used them to develop the bigger one. There is also a programming style, development coding style, where you can mix them. Some part of the code can be behavioral. Some part of the code can be structural. See, for example, for this building, structural modeling would mean already room structure is there. Just bring the room structure and keep it. Somewhere else, room structure is already given. You just bring the room structure and paste it. That is called as structure. What is meant by gate level is develop everything from the gates. What is meant by behavioral means you tell this is the building 4 floors. This you give it as input to the tool, it will convert everything to whatever. Okay. Anyway, so till now I hope you have understood what is data flow, what is structure. Now let's do behavioral. So what is the requirement of behavioral? You have to use numbers. So half adder behave dot. I'll copy the same code. When you go to behavioral, will it change? Alright. There will still be 2 inputs, there will still be 2 outputs. This will also be same. Only one thing you will notice going forward is that you have to use a reg. Behavioral style of coding. You have to use the reg. This won't be there. You have to use which keyword? Always. At the rate of star. Has it been done in the lab? See? Okay, fine. Always at the rate of star. What do you do? A is equal to A XOR B. C equal to A and B. You may say I don't see any differences. It still looks like a data flow. That is how it is. For simple design, you won't see any difference. For half adder, for full adder, you will not see any differences. For a bigger designs, you will see the difference between what is data flow, what is structural and all that. For simple designs like half adder, multiplexer, you will see both of them are same only, look same. That is how it is. Because and is and only, right? So you cannot change it to something else. So hence you won't see much difference. Okay. We can run this code also. What is that I have to do to run this code? This double slash are called as what? Comment. So I'm commenting this line. Okay. This okay. Now if I run it. So it's still working fine. So how do I confirm that it's actually running behavioral? I have to go to sim tab. See now DB, below DB what you have? Below that what you have? Always. That means it's a behavioral style of code execution. Clear till this one? Okay. This completes half adder for us. Now we'll do full adder and probably then with the fill end session. Is everyone fine? Are you okay to do full adder now? Okay. Full adder. What all inputs are there? A, B, C, E, some come C. Because I don't want to use C, can I use like this? Is it fine? What is the problem? Both will become CC, so I should not use. I should have some way to differentiate them, right? That is where carry in is CI, carry out is C. What do we do? Input A, B, CI. Output S, C. What is the first thing we wanted to do? Data flow style. In data flow, what is that we do? Assign. S equal to what? Tell me what is the sum equation? You write first simple expression A, B, or B, C, or C. This is the one, right? So is this expression correct? I mean, for writing on a paper it's correct, but when it comes to syntax, use A and B and C and just to make sure that the violation don't happen. Understood the point what I'm trying to do? First I want to make sure that A and B happens, B and C happens, then C and A, then all of them should get R. Otherwise what might happen if I don't give this these two and then R will happen, which may give me wrong result. You're getting? So I don't want that to happen. So hence I'm using brackets. What is this relates to? I mean, where do you learn this kind of rules? Mathematics, right? In board mass, to bypass all that we use brackets. Brackets will first, but then everything will. Here also same. Clear to you? Okay. Now, once you develop this code, again, what is that? You want to run the simulation, develop a test bench, and run the simulation to check that this code is actually correct. So for that, what am I going to do? Test bench full adder.p. I'm going to develop test bench full adder.p. What is the first thing I do? Include, because I need to know the definition. Now you may say, what is the why? What happens if you don't include? Let's say right now I'm including full adder.p. Without including if I run, what will happen is, I'll explain. See, my Quest simulator knows the meaning of what module. If I don't have these lines, it knows the meaning of module. It knows the meaning of which. Why it knows? But what about half adder? It doesn't know what is half adder. You and I know. Why we know? Because we have studied in the digital design, or somewhere we have studied. But models never studied half adder. So it doesn't know what exactly is half adder. You have to give the definition of half adder to it before it runs this. Let me again explain. Half adder is not a built-in word. Half adder is not a built-in word in models. Like module is a built-in word. It knows what is meant by module. It knows what is meant by reg. It knows what is meant by wire. Always initial everything it knows. But it doesn't know what is meant by half adder. So we have to do what? We have to include. When you include, the first thing that my model sim does is it compiles this file. When it compiles that file, it knows the definition of half adder. Then it will understand this. Then it will understand the line. But other than that, it won't understand. Clear? So do you all understand why we are including? We are including because the model sim doesn't have the definition. You need to compile that so that it knows the definition of full line. Then what do we do? Module, DB, in module. The standard process we follow is copy these lines, paste it here, cut this line, bring it here. Remove module, what is the shortcut to remove module? Delete the word, what is shortcut? DW. Go to the end of the word. E. Append. What is the short? A, B, and escape. This is the process actually. Now then, whatever inputs are there, change it to 1. Reg. Whatever outputs are there, change it to 1. This is the standard process we follow. Now it may be looking very confusing. Very natural. If you're confusing also, you'll also feel the same. You'll also find it very easy to do. Okay. Next, what is the next thing we do? Apply the inputs. Initial, begin, end. I can copy the same code that we had here. What is it? 12 to line number 12 to 35. Why 18? Copy and paste it. What is the only other input I have to do? See. Tell me how many such combinations I have to do to verify full adder properly? 8 combinations. Let me again repeat. A full adder can have 8 possible combinations, right? 0, 0, 0, 0, 0, 1, 0, 1, 0, like that. There are 8 combinations. So if I start doing everything, my code will become almost 50, 60 lines. That is where we will find a simple way of doing the same thing. We'll find a simple way of doing things. Okay, someone is asking. Can you please explain concept of reg and wire? When you use reg and when you use wire, how in test bench variable is declared as wire and why in design becomes reg? For today's session, it will be 100% explained. For today's session, let's not get into it. Maybe in a session or two, maybe tomorrow or next session, we'll explain it because I don't want to deviate from simple combination logic coding. Because to explain what is reg, again I have to explain hardware connections. There are two types of connections. One is reg, one is continuous. So it will deviate the topic. For today, please ignore this. Okay, Prabal, same thing to you. For today, please ignore it. In the next session, so we'll discuss why we are using wire, why we are using reg, all that. Why? What is the reason? Because I don't want to deviate. My purpose is simple. By 1 week, we should complete all 50 combinations. If I ask you to develop decoder, Verilog, you should be able to develop test bench. Then once you reach that position, then I will easily tweak. It's very easy for us to understand what is wire, what is reg. So instead of repeating these lines, we are going to do it in a little better manner. Repeat 10 times. 10 times repeat the process. Can I keep 1, 1, 1? Then what is the problem? All 10 times 1, 1, 1 only will apply. Are you verifying anything new there? No, right? Is there any use of that code? No. If I apply only 1, 1, 1 every time, 10 times, there is no use of it. That is where Verilog gives a concept called as $random. $random. Because of that, what will happen? A and A, B, C will get random values. Because I am running 10 combinations, there is a good chance that most of my combinations will get covered. You may say, what if some combination is not covered? Tomorrow when I run in a different random pattern, it will cover. That's the assumption. I probably this repeat 10 won't cover all 8 combinations probably. But next time when I run, it will generate the new combination, also missing combination. If I do this, you may say, what is the advantage of doing it? You will delete all these combinations. My code will get very reduced. You see the advantage? Number of lines gets reduced just by using repeat. You're repeating something 10 times and you're not applying fixed values. You're giving random values. Randomly A will get either 1 or 0, B will get either 1 or 0. So what is missing here? C is percentage B. CO. C. This is how. Any questions so far? So I can run this. To run this, I'll go to run button. I don't need to change this because my topmost module name is what? P. Here also, what is the name of the topmost module? P. You agree, right? Tell me. In my table example, which is the topmost entity? Is the table is the topmost entity or laptop? Table. Because laptop is sitting into the table. Top means not in the vertical position. Who is containing whom? Inside the table, laptop is present. Inside the table, laptop is present, right? On the table, laptop is present. So my table becomes the top. Below that, laptop is present. Same way, among two things, full adder and test bench. Who is the top? Test bench is the top. Below test bench, full adder is present. Then who is the top? CD, test bench. So I have to elaborate the test bench. Okay. You understood? Okay. Now I can run this. There's a problem C, line number 6. Line number 6. Where? In full adder. That is in the full adder. What is the mistake here? How do you see I? Now, let's check whether it is behaving properly like a full adder. Line number 75. Is it behaving like a full adder? A is 0, B is 0, B is 1, and C is 1. So 1 0 will be out, 2 will be out, right? So when you convert to what is it? 1 0. Carry will be 1, and sum will be 0. Everyone clear with this? Line number 76. All are 1s, right? A is 1, B is 1, C is 1. So sum and carry will be 1 1. Is that correct? Yes. You take any one of them. Is it correct? Line number 82. Right. So you will see that it's correct because we use the right equations. We have used the right Boolean expressions. That is where again comes the concept of bug. If someone has done a mistake while coding, I have done a mistake. Let's say here instead of it, I have used arcade. Is it correct now? It will go wrong, right? This process of identifying. See, here it's easy. If I show you this code, it's very easy to identify, right? I'll give you this code and tell me find the issue. Can you find? Right? Looking at the code itself, we can tell. But I'll go to some other place, let's say. Let's say somewhere here, arcade is there. By mistake. Somewhere here. Now I just mixed all the code. Now tell me where is the mistake. Tell me which line number is the mistake. So you don't know, right? You don't know the mistakes. So for a simple design like full adder, half adder, multiplexer, you can tell easily that there is a mistake. Now if I show you this code is not working fine, where will you tell? Is a mistake here, is a mistake here, is a mistake in this if condition. Hence, you cannot see the code and tell this is correct, this is wrong, you cannot tell that. That is where you need a proper process. That process is what? Generate inputs, apply inputs, get the outputs, check whether outputs are coming as per your expectation or not. If they come, good. If they don't come, then debug. In half adder, debugging was very easy and straightforward. Here, it will be very difficult. Okay, it won't be like half adder everywhere. It will be much more complex. You can see this, and it needs to understand each meaning. What is meant by this? What is meant by this? What is meant by this? Only then you'll be able to do some debugging, right? That is the. Okay. So you understood, right? So that is where the functional verification gets complex. Everyone does the same, but what we are doing today, even a very high experienced person also does the same thing. Only thing is the design he works and the kind of inputs you have to apply and the way you have to check will be more complex than what we do. So in your case, you are going to reach that state gradually. Where you are going to learn simple designs now. After a month or two, you are going to learn little more complex designs. Towards the end of the course, you are going to learn even bigger complex designs. Then when you transition to industry, things could be more complex also. Okay, fine. Now have you understood? If you run this code, you will surely get the issue. Then you have to identify where is it went wrong. So you will see that again the same observation you will make that sum is coming correctly, carry has a mistake. You will see in the pattern. Then you will come into this debug. Then like find even analyze, you will figure out this. This is full adder. What kind of coding? Data flow. Let us do now structure. You want to continue? You want to stop? Continue is fine. Another 5 minutes. Full adder. 8. It is very simple. I'll tell you how simple is it. It's off. A comma B comma C is sum. Is that line clear? Simple, right? But when it comes to this one, is there any one gate which will give you this behavior? How many gates do you require? 4 gates you require, right? So what we are going to do is we will remember that format. The full adder, gate level, gate level. Which is the diagram? Is this the one? No, right? This is a little different. Actually. This is a little different. Okay. So you have got the 2 AND gates. So what I am going to do is AND gate. Output of the first AND gate is what? N1, A comma B. I will draw the diagram also. N2, B comma C, and N3, C comma A. And all of them are what? R. C out equal to N1 comma N2 comma N3. So let me draw this diagram so that it's easy for you to understand. I'm only writing for carry out, okay? Not for sum. First you have got AND gate, AND gate, AND gate. All these AND gates are going to one OR gate. What are these? A, B, B, C, A, C. Verilog has a limitation where there is no one single gate like this. There is no one single gate which gives you AND and OR behavior. You have to implement. Sorry. So by doing that, what am I doing is I am naming it as N1, net 1, N2, because other things have a name. This is C out. Other than those 3 wires, wherever I have given name N1, N2, and 3, everyone else has a name. What is the name of this wire? A. What is the name of this wire? B. You see on the left hand side, all the inputs of AND gates have the names, but who don't have the names? This doesn't have names, this doesn't have names, this doesn't have names. So we are giving a name to them. Now you may ask, why are you giving N1, N2, N3? Why not give P1, P2? Well, you can use it. General convention is to use N1, N2, N3 because they are called as nets. This is called as a net. So hence we use N. So in going by that, this is AND gate. What is the output of AND gate? N1. What are the inputs? A comma B. For next AND gate, what is the output? N2. What are the inputs? B comma C. Next AND gate? N3, C. Then R, which R's everything. Understand? N1, N2, N3 are the inputs, and output is what? C. I mean, let's change that. I mean, cut out. You may ask why I'm not deleting. I can delete also. There's nothing like cut out. Running it again. Now, what is the style of coding I'm running? Gate level description. I'm checking whatever gate level code I have developed. Is it correct or not? So it has given me this output. If randomly check, it will be correct only. Okay. You can confirm here. This page has a DUT. Below DUT you have XOR gate, AND gate, AND gate, AND gate, and one OR gate. We will conclude this session with 2 more things. One is called as a behavioral style. Same code I will tell behavioral style. So let's make full adder. Behave. The easiest way to do behavioral is what? You take data flow, you write always at the rate of star. Star means what? Tell me. Anytime any of the input changes. And just remove a second. Right now, I am showing you the steps involved in converting a data flow code into behavioral. Let me again do that. Empty file. Pasted what? Data flow. And what did we do? Always rate star. Begin it. Remove the assign, then shift by that. This becomes behavioral style. The same thing can be done in a little different manner. This is also one more possibility. I'll explain this tomorrow. I'll explain that like tomorrow. Don't worry about that right now because You are new to this concept, but you are familiar with this. So hence, you will only stick to what you know. Tomorrow, I'll introduce the new thing. So here, what is happening is, just to give a quick background. If all of them are 1, 1, 1, 1, 1, 1, what is the total addition? 3. In binary, what is it? 1, 1, 1. 3 is 1, 1, right? So lower one will go to sum. Carry will go. So that is the result you are expecting, right? When all 3 inputs are 1, 1, 1, sum should be 1, carry out should be 1. Same way if you apply 1, 0, 1. What is the decimal value? 2. 2. In binary, it is what? 1, 0. 0 will go to whom? 1 will go to that. So is that correct output? This is another step of developing the full arithmetic. You may say, I'm going by that. I can delete this. It's also possible. You got it right. Let's say if all of them are 0, 0, 0. What is output? 0. If you expand it is 0, 0. Sum will be 0. Carry out will be 0. Now to check, to confirm this, again what do I do? Change the file name to behavior. Okay, because I'm doing behavioral style, output should be rich. For now, just remember it. The only thing you have to remember is, inside always, anything on the left hand side should be a rich. What is the guideline you have to remember? Inside the always block, any variable on the left hand side should be a rich. Okay, run it. It will also behave properly only. I mean, it will come properly only. You can check any one of them, it will come. Okay. So let us stop this session here because I don't want to exhaust you with too many things. Why I don't want to do too many things? I want you to go home and try these things. Not immediately, maybe 1 hour break you take and you do it. That is the important thing. Okay. The important thing is not attending the sessions. Important thing is, once you go home, start practicing. Sometimes you don't know where to start a session. How to type module, how to write input, how to write output. Also, you will find it difficult. That is natural. Everyone faces the difficulty, not you. Everyone faces some level of difficulty. Okay. It's all about overcoming the difficulty. Where you don't understand, you have to come to the trainer and take support. Going home, not doing anything. Tomorrow again coming and attending sessions. No use. If that is your style of study, just discontinue the course and go back. I'm telling you frankly, that is the style. You don't go home and don't do anything, think that automatically session everything will happen. It's not going to happen. In session, you're only going to learn 25% of this. Remaining 75% has to happen by your own interest. Only thing is, at times you're stuck. There you have to take this up. Okay. So we'll stop here. So please make sure that you practice these things. We'll end the session. Thank you.
Sure.